Hi ladies, it's Mr. O'Sullivan. Today we're going to be looking at lesson 1-8, the box method. This is a continuation of the lesson 1-7, where we learned how to multiply two binomials together. Today we're going to focus on actually multiplying longer expressions, all right? So today's learning target is I can multiply two polynomials by applying the box method. Your do now is pretty straightforward, using the box method to simplify those expressions, so try it. Okay, here's how you do numbers 1 and 2. So for number 1, I want to simplify 3x plus 5 times x plus 1. So I'm going to draw a box. And I'm actually going to, what is it called? After I fill in these 4 squares, I'm going to copy and paste it for the next example. That way I don't have to do it again. So paste. Perfect. So it doesn't matter where you put the 3x plus 5 and x plus 1 as long as you keep them together. So I'm going to do 3x plus 5 here, and then x plus 1 down here. We know 3x times x is 3x squared. 5 times x is 5x. 1 times 3x is 3x. And then 1 times 5 is 5. Now the nice thing is I combine those diagonal-like terms, and my final answer is going to be 3x squared. 5x plus 3x is 8x. And plus 5, and that's my final answer. All right, now let's look at number 2. Using the box method, simplify 3x minus 1 times x plus 2. I'm going to put my 3x minus 1 here now just to show you it doesn't matter, and my x plus 2 up top. 3x times x, 3x squared. 3x times 2, 6x. Negative 1 times x is a negative 1x. And then negative 1 times 2 is a negative 2. Combine those like terms on your diagonal. I have no idea why my iPad's glitching. So I get 3x squared. 6x minus 1x is a positive 5x. And then I get my minus 2. Now, we're not going to go over this one, but how do you think you would draw a box for this question? 4x minus 1 times x squared plus 3x minus 4. We're going to go over that in this lesson. So the box method for multiplying polynomials, here's what we're going to do. In this example, I want to do 2a plus 1 times a squared plus 2a plus 2. Let me just make sure I didn't write that one twice. I didn't, so we're good. So if I want to do this, you need to determine how many rows and columns you'll need for your box. So if you look... Remember, we said that it doesn't matter where we put these, right? Like our 3x minus 1 and our x plus 2 as long as they stay together. It doesn't matter where you put your 2a plus 1 or your a squared plus 2a plus 2 as long as you keep them together. So if you look, I have 2 terms here and 3 terms here. So what I'm going to do is I'm actually going to make 2 rows and 3 columns. So it's going to be a big box. I'm just going to copy and paste it in case I need it again, okay? So let's look. Step 2 says, figure out which expression you want to write on the left side of your box and which you would like to write on the top of your box. Well, obviously I have 3 blanks right here, so I'm going to put my a squared plus 2a plus 2 up top. And then I'm going to put my 2a plus 1 on the side. Now remember, wherever you see a variable without an exponent, it's really just an imaginary 1 as a placeholder. And this is really 1a squared. So 2a times 1a squared. So now we're going to multiply to determine the numbers that go inside your boxes. So 2a times 1a squared is going to be 2a to the third. 2a times 2a is going to be 4a squared, because 1 plus 1 is 2. 2a times 2 is going to be 4a. 1 times a squared is just going to be a squared. 1 times 2a is 2a. And then 1 times 2 is 2. And again, the nice thing about the box method is 99% of the time, like I mentioned 2 days ago, your diagonals are going to be like terms. So now I can actually combine some more terms. So my final answer would be 2a to the third. This is really 1a squared, so 1 plus 4 is 5. 2a plus 4a is 6a, and then I just get a plus 2. So that's your final answer. 2a to the third plus 5a squared plus 6a plus 2. Let's look at these examples where we have some binomials multiplied by a trinomial. Let me even have a trinomial by a trinomial. It's going to be so much fun. So in the first example, we're doing 3x squared plus 4x times 2x squared minus x minus 1. So I'm just going to put another box to the right because I know I'm going to be doing another set of box method. So the first thing I'm going to do is I'm going to label my box. So I'm going to do 2x squared minus 1x minus 1. And then I'm going to do 3x squared plus 4x. Now, remember this is 4x to the first, x to the first. So numbers go inside the box by multiplying. So 3x squared times 2x squared is going to be 6x to the fourth. 3x squared times negative 1x is going to be a minus 3x to the third. 3x squared times negative 1 is going to be a minus 3x squared. Now, if you notice, my exponents are going to be going in descending order. So now I'm going to do 4x times 2x squared, and it should be an x to the cubed, and it is, and it's 8x to the cubed. Now, 4x times negative 1 is going to be negative 4x squared. And then 4x times negative 1 is going to be a minus 4x. And again, the nice thing is those diagonals are going to be like terms. So after I combine my like terms, I get 6x to the fourth plus 5x to the third minus 7x squared minus 4x. And that's your final answer. Let's look at the next example. I have 2x plus 3 times x squared plus x minus 5. So let's see what happens. Put in those placeholder ones. That way you know you have to add those exponents and multiply those coefficients. So 2x times x squared gives me a 2x to the third. 2x times x gives me a 2x squared. 2x times negative 5 gives me a negative 10x. 3 times x squared gives me a 3x squared. 3 times x gives me a 3x. 3 times negative 5 gives me a negative 15. And then we combine those like terms. So my final answer is going to be 2x to the third plus 5x squared minus 7x minus 15. And that's your final answer. Let's look at our next and final example. We have x squared plus x minus 3 times 2x squared plus 3x minus 1. So I have three terms. So I'm going to have 3 rows and 3 columns. So it's going to be a perfect box. Draw your box, draw your box, draw your box, draw your box. You're going to be doing a lot of multiplication right now. So let's draw that box. Sorry, it's not perfect. I'm going to put my 2x squared plus 3x minus 1 on top. And then I'm going to put my x squared plus x minus 3 to the left. I'm going to put my x to the first, x to the first there. That way I know. 1x squared times 2x squared is going to be 2x to the fourth. 1x squared times 3x is going to be 3x to the third. 1x squared times negative 1 is going to be a negative 1x squared. 1x times 2x squared is going to be 2x to the third. 1x times 3x is going to be 3x squared. 1x times negative 1 is going to be a negative 1x. Negative 3 times 2x squared is going to be minus 6x squared. Negative 3 times 3x is going to be negative 9x. And then negative 3 times negative 1 is going to be a 3. So if I look at my diagonals, my like terms are still there. It is beautiful. So my final answer is going to be 2x to the fourth. 2x third plus 3x third is going to be a 5x to the third. Negative 6x squared plus 3x squared is negative 3x squared. Take away 1x squared, I get a minus 4x squared. Negative 9x minus 1x is a negative 10x. And then there's going to do a plus 3. And that is your final answer. So I get a mess of an expression. So that is our lesson on the box method for multiplying polynomials. If you have any questions, email myself or Miss F. Have a great day, ladies.